All right, we should be, live stream should be on now.
Okay.
Yeah, I'll have to start webinar, so we'll be live.
Oh, one person joining.
All right,
Okay.
hello everyone.
Yeah.
Good evening and welcome to our event tonight. My name is Kirk Stalkey. I'm Design Technology Manager at NOR Architects and Engineers and the Executive Director of Digital Built National Capital Region. And today we have a really exciting topic. We're going to be talking about energy modeling and how technology can help with that. Environmental sustainability and resiliency is definitely a topic at the forefront of discussion in our industry. As we all know, the construction industry contributes a lot to greenhouse gas emissions and global warming as a whole. So today we're going to discuss a few different ways that we can bring technology into what we do and hopefully do our part and make things a little bit better. So with that, I'd like to thank everyone for joining us today, and I'll hand it over to Jaylin.
Hello, welcome everyone. I'm very honored to host this event today. I'll be your moderator. There'll be two speakers today, one from Canada, Toronto, and the other one person from Singapore. And thereafter, we will have a Q&A session, and then it will be followed by the panel discussion. So if you have any questions, please use the chat box and the Q&A section in your screen. And we will gather all these questions at the end, and then we will ask the questions to the panelists. So without further ado, let me introduce Kelly Fisher. Kelly Fisher is the Director of BIM and Building Performance at KMAI, which is the architecture firm in Toronto. She's a certified passive house consultant, certified by Germany. Certified by certified passive house consultant, certified by Passive House Institute in Germany. Sorry about that. And Kelly brings a vast knowledge of both the physical reality of a construction, as well as a technical expertise in a wide range of programs. So with a strong interest in building science and performance, Kelly is passionate about making passive house buildings the standard that is accessible to all. Kelly has been playing an active role in all of the firm's passive house projects, including various affordable house projects and complex heritage restoration projects. So please welcome Kelly.
Thanks, Jaylin. So let me just get my screen up here. Okay, so I'm going to be talking today about BIM and Passive House Planning Package and how we can integrate the two. So as Jaylin mentioned, I work for Kearns Van Senior Architects out of Toronto, and we have been focusing a lot on passive house construction for affordable housing projects and just passive house methodology in general a lot over the last few years as we see this shift towards more sustainable construction and reducing our carbon impact and how we build and what we build. So I'm going to talk today about a BIM to PHPP workflow that we have developed for large-scale passive house projects. So a little bit about some of the specifics. We're going to understand the issues presented for data collection with the PHPP, and I'll get into a little bit about what the PHPP model is and how that all works in a little bit. We're going to review some of the tools that we have utilized and employed in our own internal workflow to extract data from our BIM and put it into the passive house model, generally with a lot of ease. We're going to look at how we can generate efficiencies in that data collection and what impact that makes on our large scale projects and the efficiencies and the accuracies we strive for in those large scale projects when you look at the amount of information you need. Then we're going to have a general review of the workflow that we've created and look at some of the external contexts. So I always like to get into a little bit about what is BIM. I do these types of presentations a fair bit, and there's always a variety of people who attend. Some are architects, some are more technical, some are energy modeling specialists. So I like to get everybody on the same page before we kind of get into a bit more of the meat of this presentation. So BIM is building information modeling. It is the digital representation of the built environment, and it can be used all the way through design, construction, and operation of your building. And it should be used through all of those stages of your project. So you can use it for space programming all the way through to facilities management and renovations. And why do we use it? It's experience, it provides that experience to the digital environment. It allows you to explore and collaborate and coordinate with everybody who has the ability to work in the BIM environment. So your architect, your engineers, your facilities manager, your owners, even the contractor, everybody should be in the same environment and everybody has access to the same amount of information. It provides like a visualization for the design process. So people can visualize the design that they're going to go through in a 3D element or 3D process to help them better understand any clashes or coordination that needs to happen. And what are the benefits? It allows us to digitally capture the reality of the built environment before we build it. So we can see and walk through the space and see if there's any issues that we need to address, any additional collaboration, or if we want things to look differently or run different iterations of the same design. So with that being said, I'm going to get into a little bit about what the PHPP is. So PHPP stands for Passive House Planning Package. And if anybody has done a Passive House certified project, you know that this is just a monstrous Excel spreadsheet that has an infinity of background calculations and information and a lot of data that you have to put into it. So the PHPP is essentially the energy model that you use for a certification or to test different design options to see how your metrics for your high performance building are sitting with and against the certification criteria for your Passive House project. So it's a lot of specific information that is required in that document and in that file and in that model that you have to get from somewhere. And that typically comes from your design, your massing, whatever software or data you're using. And for us, that happens in the BIM environment through Revit. So we were looking for ways to create efficiencies in gathering that data and a way for us to kind of go through all the different design iterations and variations that your architect wants to explore. And if anybody works with architects, you know that that is often a lot of different iterations of the same thing. So with high performance building, we like to say, if you have an energy efficient building, your workflow should also be energy efficient. You don't want to waste energy, you don't want to waste time. You want to get as accurate and useful information as you can from something that already exists. And for us, that's the BIM. So typically and historically for Passive House projects, the information can be taken from your Passive House consultant or from your Passive House certifier, and typically they work outside of the design team. So they take a drawing set, whether it's CAD or PDF, and then they take that in the 2D environment and they extract what they need to. But what we've learned over the past few years is that process takes a lot of effort and a lot of time. And it's great when you have a single family home. But what if you have a 28,000 square meter building? It's going to take a lot of time to get that data out. And for us, that's just a waste of effort, a waste of time. So we wanted to find a better way to use our time and a better way to have an integrated approach. So I'm just going to back up 1 second here. So before I get into our workflow, I just wanted to kind of touch a little bit on our experience and how we have dealt with this. So what we have kind of developed started in our office in about 2017, when our first Passive House project, first large scale Passive House project, was 750 bed student residence for UTSC in Scarborough. We were the project design compliance team that was tasked with creating a design for this large student residence that would meet or exceed Passive House certification criteria. So when you get into that many student rooms and that many students and that large of a building, you need to be able to get your data out quickly so that you're not wasting time and slowing down the rest of the team when you're in a bit of a time crunch for these different scenarios. So the workflow that we have created works in tandem with our existing Revit workflow, our existing BIM structure, and it has allowed us to develop and expand on that over the last few years. Now, when we started doing this in 2017, there wasn't anything really on the market beyond Design PH, which is a SketchUp plugin. And I don't like to go backwards from Revit to SketchUp. It's just not, doesn't seem right. So what we did is we expanded on our Revit content and we built a workflow that works for like our office and our setup. Now in 2021, I lost track of time there. 2021, there's a lot more things that are available to you. The Passive House Institute has the BIM to PH. Ed May out of New York has IDF to PH. All of these are BIM plugins and BIM workflows. And then there's also other things like the Design PH, which is a SketchUp plugin. There's Passive Link, which is another Revit plugin. So there's a lot more things that are available to you. Mind you, we've explored those things, we work with those things, and we still keep coming back to this. So now I'm going to show you what this is. So this process goes from functional space programming or room data sheets all the way through to our Passive House energy modeling. So when we start a project, we get the information, hopefully and typically, from the client. And this comes by means of a room data sheet. So the client has presented room data sheets, they fill these out, they tell us what rooms they want, what requirements they have to have, and specifically, hopefully, what size those rooms have to be, what purpose they need to be. So we've created a set of specific room data sheets that we're then able to export to a more legible, organizable format into an Excel document. So we take the site and function space program review, and we take that information from the room data sheets and we turn it into an Excel document. And then from the Excel format, we're able to use Dynamo. And many of you might already know this, but Dynamo is a visual programming software that allows you to take elements from a 2D environment like Excel or a CSV file and turn it into a 3D shape if you provide the right parameters. And so after we do that, we're able to then extract those parameters and those room sizes and the demographics for where they need to be placed and generate a massing model. And I'm going to show you how to do this here in a second. So after we get all that information together, we then are able to finalize a massing. So now I'm just going to show you a quick little video of this workflow, and it helps really explain it.
This is a workflow that we have developed at KMAI to assist with space planning, which allows us to easily review spatial relationships and assignment visually. We call it LEGO BIM because we use a BIM workflow to create blocks in a 3D environment to build early project massing. These blocks are created using predefined room information provided in room data sheets specific to the needs of the project. This information is extracted to an Excel table where we assign colors for each usage type of department. This helps us to organize the spaces visually for analyzing relationships between each use type and occupant requirements. We then use Dynamo, which is a visual programming software, to take the information from the Excel table and transfer it to the BIM model. This script will then take the areas, names, and color assignment and create 3D blocks which are ready to be laid out to create preliminary massing. Each block comes loaded into a project file with all the information extracted from the original datasheets. As we click on the blocks in the project file, you will see on the left-hand side of the screen information particular to each block from the original room datasheet. We then need to explore the confines of the site, so we know the limitations of the massing we have to work within. For this project, we have very little wiggle room for the massing, as you can see. As the finished model fades away, you can see the process of laying out the blocks and how we can see the color assignment to each space. This workflow also has checks in place so that we can export the shapes after building the blocks to check the final areas against the original requirements. Because of this workflow, we are able to take the functional and operational requirements and wrap the building around those. This workflow has become an integral part of our BIM process.
Okay, so that's the first step in our process, where we take the information that the client has given us and we turn it into a massing that explores all the spatial relationships between each of the items. And then after we have our massing, then we start looking at how we're going to start putting everything together so that we have the content and the information we need to extract our to our passive house energy model. So for us, that meant Revit content creation, and who doesn't love Revit families? But I do, so it's great. So we made doors and windows. We've made special families to track our thermal bridging, which in energy modeling is a junction where you have a significant portion of heat loss. And when you're doing high performance building projects, you have to analyze every aspect of your building that has heat loss, because you have to be able to track your overall energy consumption. So when you get into large buildings, and you can see here these red lines at the top, is an outline or an axiometric view of all of the thermal bridges for our PDC project for the UTSC student residents. And what this allows us to do is extract and visualize where all the thermal bridges are happening, and also quickly quantify what all the lengths of those are.
Kelly, sorry, we don't see your screen.
Oh,
Can you maybe reshare your screen?
I thought I did. Can you see it
Oh
now?
yeah, perfect.
Okay.
Yes, thank you.
Sorry, I'll remember after my next video. So sorry about
Right.
that. Okay, so here's our contact creation. And we've got thermal bridges up here, which I just spoke to. We also create windows and doors. We've set up special parameters to track our area that we need to for passive house, so our treated floor area, and parameters to track exterior wall areas as well. Outside of that, we also, this is just a couple snips of modeled components. So you can see when you get into these larger projects, we've got a lot of glazing, we've got a lot of thermal bridging, we've got a lot of pipes and ducts in the building. And generally, a lot of these need to be quantified, and they need to be quantified quickly and on a design iteration process. So they can happen quickly, and you need to be able to extract that information as you need to. And here's a bit more example. So we're coding everything with special parameters that we build into the Revit content. And this allows us to easily extract that data as it's being modeled and automatically link to our passive house energy model. And one of the additional benefits of using BIM is for all of our, most of our projects and all of our passive house projects, we get all of our engineers and consultants to use Revit or BIM. And what this allows us to do is quickly quantify things. So when I talk about heat loss in a high performance building, you have to be able to analyze everything. That includes how much domestic hot water piping you have in your building, how much sanitary vent pipe you have in your building, and the ductwork you have in your building. And when all of this is presented to you in a 3D environment, you're able to quickly write a schedule and filter everything out that you need to, and very quickly actually put all that information into your PHP file. Okay, so after we create all of our content, we create all our families, we code everything we need to code, and we've got everything set up and organized, then what we do is create a bunch of specific Revit schedules to export all of that very specific information into our passive house model. So here's just a snip of some of the schedules we would work with. Windows, we can have up to 800 windows in a building, treated floor area, exterior doors, lighting that's provided in the project, because you also need to account for how much lighting you're providing, as it's an energy source that you have to properly calculate. And so after that, we go back to Dynamo. And the nature of all of this is the end product that we need, that we're looking to get to, is an Excel file. Because the passive house planning package is a monstrous Excel file, but we're able to tailor that to our needs to get the information from the BIM environment into the Excel file that is essentially the passive house planning package. And now I have another video for you, but I will remember to turn the screen share back on this time.
This is a workflow which we have developed for our passive house projects. Using the same BIM as the architectural team, the passive house consultant is able to extract required information from the project into the PHP model. We are able to extract project-specific information for windows and doors, thermal bridges, room areas, and wall areas directly to the PHP using information isolated in custom BIM schedules. With the integration of Dynamo, a visual programming software, we are able to take the model and the project schedules and directly export them into the PHP model. This is a master PHP model, which is linked to pick up this project information immediately after exporting from the BIM environment. This workflow has saved us countless hours as we work through the many design iterations for the final building massing in the design of the project to meet Passive House certification standards.
Okay, so that was the second video of the process where we take our modeled components and our Revit content and we extract it into a PHP file. And that PHP file or a PHP model is how we evaluate where the design that we've got is running up against the Passive House certification criteria. When we work with a bunch of different design iterations, especially through schematic design development of our projects, we have to be able to assess changes in massing, changes in orientation, changes in window to wall ratio, changes in building envelope area rather quickly to be able to provide that feedback to the architectural team to better improve their design, to be more favorable for the compliance to Passive House. So using the Revit massing, design info can be input to the PHP to calculate the compliance. After that, we would review the orientation of the model, scenarios that would maybe favor the energy model any better to improve the performance of the building from a more passive approach. And then we would review the systems like M&E to see if there's any way that we can work to lower or minimize our energy demands, improve our space heating and space cooling metrics, things like that that we'd be able to work with in tandem with other disciplines. And additionally, the same thing, we'd work with our M&E to see if there's any equipment efficiencies or anything like that that we can kind of come together to improve the overall performance of our building. And after all of this is complete, we've had the feedback from the client, we're able to present everything quickly and accurately with our results to ensure that we can achieve our certification for our energy model, and also something that the client is happy with from an architectural standpoint as well. So this is just a bit of the workflow that I've covered already. So this ones on the left here is what we start with when we're looking at our spatial relationships and our massing model and how we generate all of that from our room data sheets and functional space programming. And then when we take that and we run it into our energy modeling process and our workflow, and we go through the different iterations with the design team to see what works best. And at the end of it all, we end up with a massing model that works for Passive House, works for the architect, and works for the client. So in summary, BIM does what we need. So we have to find a way to make it work, to make the information that we're already generating available in the other aspects of things that we need to do. So when we get into sustainable construction, high performance building, we need to be able to make those decisions quickly, and we need to be able to get that information from a relevant source, and a singular relevant source at that, because when you're working at different workflows that maybe take you into SketchUp or take you into Rhino, there can be some issues with that because you might be working with something that's slightly out of date, but when you're working in a concurrent process, it allows for a more entwined and iterative process. So yeah, harnessing the potential of the existing software. So our whole mantra, because we're a smaller firm, is we like to see what we can do with what's available to us through open source methods. Dynamo is a free platform. It works well with Revit. So why not spend a little bit of intuition getting something that works without a significant overhead cost, but also works with our existing workflow. And we've been able to accomplish that with this setup using Dynamo and the PHP model and our Revit projects to work cohesively and collaboratively together. So all our information lives in one place, and the design is a concurrent process throughout the architectural process. And thank you. I think I may have talked too much, but Jaylene, or talked too quickly. Jaylene, you'll have some questions, I'm sure.
Yeah, no worries. So thank you very much, Kelly. That was fantastic. Actually, we have a little bit of time before we move on to the next question, the next presenter. So I'll just ask this question from the chat. What about Open BIM standard and PHP? As far as I know, Passive House Institute released a new tool for exchange of IFC. At Building Smart International, we are dealing with standardization of BIM and BEM. See follow press release. So he attached the link. Do you have any comments on that?
Yeah, so I've played around with the Passive House Institute and their tool as well. It's a great tool. We've used it for a few things. We just seem to favor our own process. There's lots of things out there that you can use. There's lots of things that may work well for your structure and your environment. Use what works best for you. And a lot of the things that are out there, like with PHI, are really great as well. So it just depends on what best suits your workflow and how you want to go.
And what about is there other softwares or Revit plugins that kind of does similar to what you do and make it maybe even easier for data export?
So what we've developed does require a bit of user knowledge with Dynamo and writing the scripts. There are other platforms out there. I think I mentioned at the beginning, there's Passive Link, which is a Revit plugin. There's IDF to PH, which is coming out of New York. From Ed May in his office, and it's a fully integrated BIM process as well. PHI has BIM to PH. That's their workflow. It also works on the IFC format. So there's lots of different options available. It just depends on which route you want to go and what works best for you.
Great. So finally, before we move on, what advice would you offer to passive house designers who are just getting into the industry and wanting to work with the standards and working with BIM?
Yeah, so there's lots of stuff in the passive house industry when you're looking at energy modeling or even workflows or even construction methodology. There's lots of webinars or things like that you can attend. And one of the benefits, I don't say this often, but one of the benefits of COVID is there's a lot more stuff online now that you can watch from the comfort of your own home. So there's lots of things that are happening every other week, once a month in the energy and sustainability community, and especially through Passive House, that are free for you to attend. And you can network with industry peers to get more information and to get more awareness of what it is you're trying to do. Somebody has usually already done it before. So you just have to find out who that is and poke their brain.
Yeah, okay, that's perfect. Actually, the question earlier that we asked from the chat, I said that my main question was concentrated on open standards like IFC, Revit workflows, is a closed BIM.
Yeah, we don't work a whole lot with IFC formats from like an open BIM perspective. We're a smaller firm, so we've tailored this to meet our needs. But I would love to get into more of that stuff. It's not something that we support right now, or we have any interest, because our projects are large in scale, but not large in quantity, I should say.
Okay.
We've only got, I think, a handful. I think we've got 5 or 6 Passive House projects right now. So maybe when we get a few more in, we'll expand.
Okay, perfect. We have a few more questions coming up. Actually, from Nilesh, another presenter, we'll ask you before we get into Nilesh's presentation. Are the tools you use and the methodology commercialized so that others can use this tool? Is this part of a plan?
It's excuse me, sorry. It is, the methodology is commercialized, like everything's available for you. It's all free. Well, I say that Revit's not free, but Dynamo is free. So if you already use Revit, Dynamo is available to you. And a lot of the information that we were able to kind of research to figure out what we needed to do a few years ago was all available online in the various Dynamo forums. So people are doing it in just different ways for different applications. So we took that and used it for a different approach, which is what you see here.
Okay. There's a very interesting question, but I'm going to save this one for later when we have a Q&A later. So let me just introduce you to another presenter, Nilesh Jadhav. Nilesh Jadhav just joined us from Singapore. It's very early in the morning, 5:30 a.m. So thank you very much, and kudos to you. Nilesh Jadhav is the founder and CEO of Chi Square, and is a Singapore company focused on digitizing the building industry for a sustainable future. And he's a passionate clean energy technopreneur with more than 20 years of industry experience. His experience spans across technology development, operations management, R&D outfits, and startups in the clean energy space. He has been actively involved in clean energy policy development through participation in projects such as Singapore's energy roadmaps with the NCCS. I have to ask you what this NCCS is later. And sitting on the boards of government and semi-government institutions such as the Sustainable Energy Association and Singapore Green Building Council. He is a published author of a book called Green and Smart Building and Advanced Technology Options in 2016, and also a visiting professor of many universities in Singapore and India. Okay, please welcome Nilesh Jadhav.
Hello. Hi, everyone. Can you hear me okay? All right. Thanks. Hello, everyone. I just went through the participant list quickly. I didn't expect to know many people here, but I figured out I would know probably a few of you. So that's great. And thanks, Jane, for the kind introduction. My talk will be a bit different than Kelly, I believe. I think Kelly solved a problem which is really in the design stage of the building, which tends to be quite complicated. And one of the issues from the business side that we see is that architects and clients will keep on changing their mind. That is absolutely true, Kelly. So we are actually focusing on existing building retrofits, and that's our clear purview. And the tool I'm going to present is a cloud-based tool, which basically, of course, the complexity of an early stage design is then no longer there. Your massing and everything doesn't change in a retrofit. So essentially, that's a tool that I'm going to present. Let me just share my screen and see if this all works. Yeah. Okay. Can you just help me see, make a thumbs up or something if you can see my screen? I believe you can. Yep. All right. Okay. Excellent. So let me just go further now. So yeah, again, Kelly kindly introduced, Jaren kindly introduced me earlier. My name is Nilesh, and I'm the co-founder and CEO of G Square Private Limited, Singapore. So yes, it is quite early in the morning in Singapore. So please pardon me if I get a bit astray sometimes, or if I don't make sense. I would try to make sense during a Q&A. It's still early, still waking up. So what I'm going to talk today about is our latest platform called Better Life, which is a digital green building market platform where we use AI-powered green assessment as a service methodology. So essentially, we are putting the entire methodology of doing assessments and green building consulting on a cloud mode, where any consultant or building owner or sustainability manager can go in and do quick assessments. Albeit they will be lesser accurate in the beginning, but they will enable business so that you can move further quickly on your projects. So let me just go further, if everything is fine, just to maybe quickly introduce our team and myself a little bit further so that you can also help you and shape your questions later on and know where we're coming from. So we are a company which is a spin-off company of the NTU Singapore. NTU, the Nanyang Technological University, is one of the one of the three, I would say now, technological universities in Singapore. And NTU Singapore is kind of a fast-rising university, young university relatively, compared to the other university, which is NUS, the National University of Singapore. So we are a spin-off from there. We came out of the completely moved outside the university 2 years ago, and we've been fully commercial since then. Essentially, it culminates 10 plus years of R&D, 9 years of R&D that we did at NTU, probably more than that. And we have our own AI algorithms now to go further into the commercialization. Okay. So we also have a good team that in place. So we have we don't have a huge team in place right now. We have 8 people, which are a good mix of industry practitioners, technology, and business people, as well as people from the finance background. So, and also, of course, as you could see from my profile, we're also quite well networked in the built environment industry globally. And I would actually love to network with all of you in North America, Canada, world. And that's why I accepted this invitation from Jalen to speak here so that we can actually find more collaborators in that region. We've actually been well funded. So we closed our seed round, and we have been also awarded government grants in Singapore to be able to hone on our skills on machine learning and AI development so that we can actually bring up this platform called Better Life to the market. Okay, and last thing to do before I move on with the topic is just to quickly also talk about my background so that again, Jalen has already introduced me, but just to quickly mention the touch points that you might get to me later on. So yes, I basically have been working in the industry for 20 plus years. Admittedly, I've been not involved with green buildings for that long. I've been involved with green buildings for, I would say, the last 8 years. And within that span, I've been fortunate enough to work on some excellent projects in research as well as policy advice. And I also published a book. I've been also active in the entrepreneurial scene. I've actually started 4 companies. And like what Jerry mentioned, not many, but I teach at one university in Singapore and one in India. So basically, I teach modules around energy systems management and green buildings. I've been also involved with the National Climate Change Secretariat, that's the NCCS for you. Again, this might be a thing in my presentation that we use abbreviations. In Singapore, we use abbreviations quite a lot. So if you're not clear with something, please type it in the chat and I'll be happy to make it clear. So I was also involved in developing Singapore's first building energy efficiency technology roadmap. So this roadmap basically covered how building science could evolve in Singapore. And I think you have to note that Singapore is a small place and with limited R&D budget. So a lot of things are not kind of going to be started from the scratch here. So for example, we are looking always at innovating how we could actually tackle with the humid weather and the hot weather that we have here and designing air conditioning, but probably we will not go to the scratch of starting with a new refrigerant chemistry. So there is a limitation on what kind of early stage R&D that we do here. And that's why the technology roadmap was useful in finding out how Singapore is best positioned to work on any kind of R&D in this domain. The other thing I would like to mention is the Eco Campus initiative. This is a very interesting initiative that I was involved in when I was working on the campus. So I was with the university for close to 8 years, I would say. And then in that time, I was actually working on for 5 years in this Eco Campus initiative, which was an initiative all about making the campus green. So it was about walking the talk. That means if we are professing or researching on green buildings, what kind of active participations could we get? And we had 200 buildings on the campus. A nice test bed could happen there. And we ran to the Economic Development Board, got a good 20 million funding from the government. And then we set up a kind of living lab philosophy or a large test bed where we could use the campus buildings to do some further work. And in fact, that also led to this company idea that I have today. I've been also involved with Green Mark certification, which is a certification equivalent to LEED or BREEAM that you might know from your area. So Green Mark certification is used for certification of buildings in Singapore. And I was specifically involved in developing the Green Mark certification for laboratories, along with the I2SL, again, an abbreviation, sorry. It's the International Institute for Sustainable Laboratories. It's based out of the US. Some of you might know it or may not know it. But essentially, we had formed a local chapter of the International Institute of Sustainable Laboratories, I2SL, here in Singapore. And through that, we developed a certification mode for laboratories. And I've been also working on a portal for the government called the SLV Smart Hub, not so relevant for this talk today. SLV is super low energy buildings. So if anybody is interested in this topic, I'd be happy to elaborate more later. Also do mention also maybe Jalen already mentioned about my involvement in the industry networks such as the Singapore Green Building Council. I just maybe want to highlight the last one, which is the International Sustainable Campus Network. It's a nice network. I see that many people have not found it yet. If you are based on university campuses or you're part of campus greening projects, do look for the International Sustainable Campus Network. Essentially, it's a good kind of peer-to-peer knowledge sharing platform where you would be able to discuss and talk about what projects you have done and what is your how you are actually going to share that with the international body. So we had several campuses in the North Americas as well. We had Harvard, Yale, we had UBC from Canada, and I've also visited UBC I would say about 6 years ago now already, where we talked about how this what we could learn from the UBC campus in Canada and how we could apply that in Singapore and vice versa. We share the knowledge from us as well. Okay, so I thought just elaborating my background a little bit more so that we could have more touch points on different topics that I will discuss today. Okay, so in terms of our company, basically we have also done quite a fair bit of work in Singapore as well as outside. So we are practically, I would say, 2 years old. I left my full-time job at NTU in March 2019. And that's why we started full swing on the operations of the company. We've been able to work with several clients in Singapore, and some of you may or may not know these companies. Singtel is a large telecom provider in Singapore. DBS is a bank with a good portfolio of buildings and assets in Singapore. Hilton, probably most of you know, it's a provider of hospitality, and same as Fraser Hospitality. JTC is an industrial developer, and Macadis is a operator of shopping malls and retail outlets. Land is an office building developer, and Sembcorp is an industrial building developer. So essentially, these are large-scale developers in Singapore, and each of them has a large portfolio of buildings, between 15 to even up to 50 buildings in their portfolio. And then we help them to see how we could achieve 20 to 50% energy savings with our quick auditing approach. We call it virtual audit in the beginning, and now it's all entirely coded onto the Better Life platform that I'm going to talk about. We also work internationally with several organizations in Middle East, in India, in Europe, as well as in our region, such as the Philippines. We're helping the Philippines Department of Energy. They just recently came up with a new energy code, and we're helping them to see how that code could be supported by digital technologies. And I think that's the benefit of the developing world, and what we could learn from, let's say, Canada and many places in Europe as well, that the energy codes and the maturity of green buildings is still in the early stage, or in some places maybe in the early to mid stage, and there is a lot of opportunity to go digital right from the beginning. So if you have ideas around that, if you think there are quick ways to collaborate, that would be a great opportunity, and you can reach out to me to see how we could bring it to this region. Okay, so maybe having said that, I'll now go into the topic proper. What problem are we solving? One of the things that we see in the industry is that there's a lot of defragmentation. The industry is not that well organized, I would say, having been a consultant in the industry for quite some time. And we've identified these 4 key stakeholders: the building owner or the building manager, let's say, the consultant who advises the building owner and manager, or the ESCO company who does that to some extent. The product supplier, basically there are several green products, and that's why in my book I've highlighted more than 100 green products that you could adopt in green buildings today. And there is also a play on financing, because that's an area which is evolving quite a fair bit in the recent times. You know that green financing, green bonds are becoming more prevalent and attractive and easily available to the industry. So the problem that we have seen is that there's a lot of lack of communication, primarily because of data structure and exchange. So as a consultant, when we are doing certification projects, and some of you who are consultants would also identify with this, that when we started a project with, let's say, for recertification of a building, and that's why I said existing buildings is our domain, we see some frustration around the data gathering, because existing buildings tend to be, some of them could be quite old, and the previous consultant has done a fantastic job, but has not handed over the data to the building owner or to the building manager. And because of that, the next consultant which comes on board does not have this data to start with. And of course, it means 2 things. One, it's going to be more time consuming and more manual labor. And because of that, it's going to be more expensive. So that's the issue with the market today, at least in Singapore. And maybe it's also the same. And please share with me later on in your Q&A whether you also see that problem in the markets that you are in, that this tends to be quite an expensive and manual proposition because of the lack of data. If there was a good amount of data available, just like what Kelly shared earlier, it was going to be possible for us to actually put that data all together in a nice digital format and then advise the industry clients better. It also tends to be quite slow and limited because of that. So the pace of green buildings that we all desire is not happening at the same pace that we want, because of the fact that things are slow. I mean, there's literally a manual process going on where a consultant would get up a job after an open tender, then look for technologies to put into the building, especially in the retrofit mode, then look for financing, put it all up together, make a project, make a good value proposition for investment, and then carry on the project. So this thing should be quite slow, and because of that, retrofits in buildings tend to be quite limited, unfortunately. So people, for example, in Singapore, only look at the central air conditioning or the central chiller plant. In Singapore, we do not even call it HVAC sometimes. We call it ACMV, air conditioning and mechanical ventilation, because heating is not a problem for us. So essentially, the air conditioning mechanical ventilation seems to be the biggest energy consumer, and specifically the chiller plant tends to be the biggest consumer. So people focus a lot on retrofit of chiller plants to higher efficient ones, or putting variable speed drives in chiller plants. But the holistic view is not taken of load reduction first and then going towards a better chiller plant. So of course, a lot of the design stage issues will be already sorted out in retrofits, but oftentimes we know as consultants and experts, and also the practitioners in this area that you might be, that building design leaves a lot of room for improvement later on, unfortunately. And with the tools which are available for building design, this problem will change slowly, and we stand corrected as to how we could actually add more value to the retrofit industry, apart from having work done in the building industry, in the design stage as well. So that's the problem that we're tackling. I think all of us knows about the opportunity, so I may not want to emphasize too much on this, but these are the two trends that we actually are kind of really using coordinating our business on. First is the green plans. So Singapore recently also announced its green plan, literally in 2 months ago, February. Singapore announced the Singapore Green Plan, and I'm sure that there are green plans available in your part of the world. There is a EU Green Deal. There is a Green New Deal in the US that I came to know about as well. And of course, green buildings are a big part of all the green plans. In Singapore, a big section of the Singapore Green Plan is focused on buildings. Singapore wants to have, for example, 80% of the buildings being green certified by 2030. And Singapore is not looking yet at carbon neutrality of buildings, but that is still in the pipeline as renewable energy gets more and more promising here. So around the world, we did a quick estimation that there are about 25 million large buildings. And the definition of a medium to large building is a building which consumes more than $1 million in terms of US dollars of energy consumption in the building itself. And of course, all of you know these figures, that there is a large contribution of carbon emissions as well as energy use. The International Energy Agency estimates there is an estimated 150 billion spent on greening existing buildings. Right? So in building retrofits, there's a large amount of spend, and this is growing at a 9% compound annual growth rate. That means at around 2031, this number is going to be practically doubling. Okay. Then the other trend on the right-hand side that I show is the fact that it's digitizing, and that's where we are today, talking to this group with several different topics such as IoT, cloud services, digital twins, big data. The topic that I'm actually particularly interested in is the data transparency. So this is one of the images from one of the articles that I published on LinkedIn, and I've given the link there later on. When you get to slides, you could see. Again, in view of time, I won't go to details of this, but what I've tried to do is to see what lessons could we learn from COVID in terms of data transparency in the built environment, and what are the so-called the viruses in our data transparency in the built environment, such as over design, such as putting the blame on different sets of institutions like an architect, put blames on an engineer and on the build and on the client, etc. And that basically hampers the progress of a good design, and later on that brings up a different problem for retrofitting buildings. And unfortunately, the data transparency is not helped anymore. Right? The data transparency is still quite bad. So once we solve the data transparency issue, we see that there's a excellent trend that we can catch on with all the things which are available. And that's the reason I asked Kelly also about the question as to how the methodology is commercialized. It's always good to use open source modeling tools. And that's a discussion we could have later. But again, if it's commercialized in a way that it could be brought forth in a very clearly packaged or a containerized way, then more and more people could be benefiting from that, rather than relying on experts who may not be found in every project. So these are the two things that I would love to talk more about also later on if you have time, but I'll just move on for now. So, okay, maybe just coming to what we have done. So what we have done is develop a solution in our research to make green assessment as a service. So what we now have is an AI-powered remote energy assessment tool. We used to call it virtual audits in the past. Now it's called the Better Life platform. So what we do here is basically we take open source data from building standards. So we start with ASHRAE templates. We start with building standards in the local environment, and then we use other openly available or building modeling tools such as BIM if it's available from the design stage. In Singapore, the involvement of BIM is still at an early stage. I mean, of course, it has been used and almost mandated in some projects, but it's not that prevalent, especially in the retrofit stage of the building. So what we do is to use that leftover BIM asset that people have during the operation stage of the building. We can kind of revive that and create a digital asset of the building. And of course, this tool is then incorporates the building physics and the data that we can get from the real-time operations. We combine these two together and make a nice digital asset, which is now also calibrated to the right standard. So we sometimes use ASHRAE 14 as a calibration methodology, or we use IPMVP thresholds to calibrate our models. And using that, once the models are calibrated, then we could use the things that we see on the right-hand side. Like we could do energy and carbon analysis, operation analysis, we could do technology fit analysis, we could do retrofit advisory, we could do financial due diligence to check, what kind of, let's say, technologies are working best and what kind of return on investment can we achieve from each of them. So that's basically what the tool does. And I'm going to explain a bit more about the technical details, since you guys are all experts in energy modeling. So I'll touch upon that a little bit. So essentially, what we are fulfilling is a kind of a level 2 audit virtually, or using the data and the modeling approach that we have. So most of you might be familiar with the ASHRAE audit levels. So just to recap for those who are not, the level 1 audit is more of a preliminary audit, which identifies no cost or low cost energy saving opportunities, and gives a general view of what potential capital improvements you could do in the building. And also, it has activities that include assessment of energy bills and a brief site inspection of the building if required. So that's a level 1 audit that one could do for a building, to just do a very high level analysis and identify some quick wins and low hanging fruits, as we call it. Then in the level 2 audit, you would go into more details. Oftentimes, people use energy modeling tools at this point of time, if possible. The problem is that the cost of energy modeling tool and hiring the experts who can do energy modeling becomes prohibitive sometimes for the building owner or the building manager. And that's the reason that sometimes it ends up with a survey and analysis kind of an approach. So people would typically identify, again, low cost opportunities and energy conservation measures in more details, and provide those recommendations to the financial plans and how it could have capital intensive operations or capital intensive assets being also deployed to exploit more energy saving opportunities in the building in the long run. So typically it also includes an in-depth analysis of energy cost, energy usage, and the characteristics of the building, and a more refined survey of how energy is used in the building. So that's basically a level 2 audit typically. That's what we classify as. And the level 3 would be an investment grade audit, which will provide more precise recommendations and financial analysis for major capital investments. In addition to level 1 and 2, it will also typically cover monitoring of data through smart meters or any kind of meters, more of data collection and engineering analysis. So what we have done is basically to look at this problem and say, what are the issues happening in each stage of this audits for existing buildings, and why sometimes the process is slow. If you remember, the goal of our setup is to see how we could actually make things more smoother, more easier, more quick in the industry, so that green building retrofits become more popular, at least in our part of the world, where it is not right now. And then also it becomes cost effective, that cost is no longer a prohibition in adopting green technologies. So at level 1, I think there's not much to do. It's anyway a quick assessment. So we actually have, what we have done is we have created an open source benchmarking tool. I'll show you later on in the platform demo, where we use open source building data, map-based models, quick block models that we could do to do building comparisons, and then basically come up with energy saving opportunities as a level 2 audit. So we are fulfilling, as when you see later on the tool that we have, it basically fulfills a level 2 audit kind of prescription that you could get for a building. We are not going to level 3 yet. That's our target in the future, to reach a level 3 audit credential. But that will be possible only by integrating real-time data and monitoring and doing further engineering analysis in the building. So I just thought of mentioning this so that when you see the tool later on, you would know where it stands and what kind of expectations you have from the tool. Okay, so now what are we bringing? Having said that, what we deliver exactly, what are we trying to achieve in the industry for, especially for green retrofit projects, is to avoid the expensive middle person that might actually take up a lot of time and resources by actually linking the two sides. And that's why you see the left-hand side and right-hand side here. The building owner, who typically is a decision maker and buyer, assisted by the consultant, and the product supplier, which is going to supply the right products and retrofit opportunities to the building, and the green financier, who is then going to possibly put a finance mode if it is not available with the owner. Also, the travel part of the assessment is taken care of. So actually, we practically started this just before the pandemic rolled out, and just nice because then we were able to do assessments completely remotely without the need to travel. We have done assessments outside Singapore as well by just getting all the data, BIM file, CAD drawings, even manual drawings sometimes, and converting them to operational energy models that we could then use for our assessments. And the other thing that I personally see as a winner for consultants is the duplication of efforts, because like I highlighted earlier in my example, there tends to be a lot of duplication of efforts when we go to the market because of lack of data structure. Things which are already done by one consultant are repeated again, and things which are done by one sector of the building manager because of the fragmented nature of the industry is kind of duplicated again. So we could actually avoid that by having a nice structure and networking this digital asset that we create. So the values for the building owner and manager, if they like or not, is the fact that they could now do a low cost and quick assessments. So the clients that I mentioned earlier, the banks, the telecom operator, they were able to use our tool to do very quick assessments instead of waiting for a consultant to take one building at a time, but actually assess the entire portfolio very quickly in a matter of weeks. If they want to, they could also do continuous upgrades and performance upgrade opportunities that they could have over time. So, for example, building owners in Singapore typically would look at this kind of opportunities only at the certification stage and the recertification stage. That typically happens once every 3 years. But now, with the possibility of a digital tool, they could look at it as a continuous mode operation. And also, our tool basically is not pushing any particular technology. We are objectively putting all technologies up there. So we offer a neutral impact assessment platform for building owners. So if they want to do a very quick assessment of a technology that they saw in a trade show, let's say they saw a nice technology for CO2 capture, which avoids your, it kind of works in a mode of a demand control ventilation and avoids a lot of fresh air intake, which is very expensive in Singapore because of the outside air humidity as well. Then you could actually do an assessment by just dragging and dropping the technology in your building, rather than waiting for a consultant to be onboarded to just do that evaluation. So this is a quick way for us to actually get further with green projects, rather than waiting for the usual process of doing assessments manually. On the other side of a green product supplier, they would actually now get first-hand visibility through quantification and qualification of their technologies in buildings. So if the digital assets of buildings are available on the other hand, the technology specifications could be also digitized and matched to the building asset, thereby creating a way for the technology provider to get a first-hand view of how their technology could perform and quantify and qualify their technology for buildings beforehand. So oftentimes a good sales tool for technology suppliers is a case study that they've done. So instead of showing a case study, you could actually show an actual simulation for the client building before even before meeting them. It also provides an aggregate city scale data. So basically, all that we will see later on, the platform is made as an open platform where you could actually aggregate data, and that's where our algorithm works, really to provide insights as to which are the green products which are mostly used, which are the most popular technologies, and which are the most energy saving technologies in the market in any city. That could be actually made to an aggregate script that we have, and that data could be made available to the participants in the market. And same way, like the building owner manager, they also get a trusted platform now to basically offer their solutions. Instead of actually pushing the solutions aggressively in a sales pushy way, they could now have a way for them to put their technology parameters online and get the building owners and consultants to drag and drop the technology into their buildings. So it kind of makes a nicely networked digital assets for easy data exchange, and that's our goal. So how would you visualize this? So this is the Singapore skyline, at least the central business district. The question we're asking is, could you assess each of these existing buildings without really stepping into any one of them? And that's the question that we asked ourselves. Is it possible through open data and AI? So what we did is basically to start with mapping tools and then put all these buildings on create their digital assets, starting with block models, and then provide a way, just like what you do in a Google map today, to click on a building and look at information. Later on, I'm going to do a platform demo, so you will see more of that during the demo. So essentially, now what we have done is we have digitized more than 10,000 buildings in Singapore, and it's still at an early stage. We are looking at several other cities. We had actually explored some partnerships in Canada, and we could come back to that again. We are also looking at other parts of the world to see how we could actually digitize entire portfolios and the entire city models of buildings, starting with simple models We're also providing options for user to add data and further improve the models for our calculations. So the approach that we have is to, again, go with that digital twinning approach of having open source data, and also now through the platform offering a easy user input tool for the users of the platform. The users would be typically the parties that I mentioned earlier, the consultant or the building owner or the technology supplier, and also the financier. So if they could actually provide data about their different aspects that they deal with, I mean, the financier could also provide data about what kind of ROIs are they looking at, and that becomes like a general knowledge for the city in terms of the aggregate knowledge that typical financing schemes would look at for, let's say, for a green bond. Then we will be making the data available in a way that is readable by every industry participant. So that basically, once that data is made accessible, we would then further combine API integrations. So we would actually integrate with several different participants in the industry, such as the IoT suppliers. So we are not an IoT company. Essentially, we look for IoT partners who could actually provide us data in exchange for our analysis and insights that we will provide back to them. We are actually working with several partners around the world to write projects together to see whether we can get grants in that area to then develop this citywide platform together in that particular city. We also can work with PropTech companies, which can provide us information around what's happening in the latest stage of the building. So although we start with design stage data through BIM, we could then improve and evolve that data over time with a good integration with the PropTech company. So for example, if a company is providing services in the bidding and procurement, e-procurement services, you could actually use that data to see, excuse me, whether the involvement of building can be captured as a data source, and whether that could be used to improve our platform database. We're also having talks now to certification bodies, where we can actually exchange data directly with certification bodies, so that we do not need to work on certifications on an ad hoc basis, but rather we have the data available, and with a few click of buttons, we could come to a very quick pre-feasibility analysis of whether in a LEED or a green mark, as we call it in Singapore, if we get to a platinum level, and what kind of efforts are required to reach there in terms of energy savings. We also are talking to utility providers. We're participating in a program called Free Electrons, which is basically providing opportunities for utility providers to exchange data and see how the data could be used on a real-time basis to calibrate our models. Of course, BIM is an important component that we could get. And of course, GIS data is another component that we always have on the platform. So what we're doing is basically aggregating all this data together, open standards, user data, API integrations, and then basically we have our own backend simulation analytics engine. So just to give you an idea, since this is a technical crowd, I actually have another slide on that, but we started by using easily available simulation tools in the market. But then basically we kind of made our own simplified models, scripted them in Python, and then put it on our cloud platform. So that's the methodology that we use to basically capture the building physics models, simplify them wherever required, and try to still get a decent amount of decent accuracy that you can get for the models. And the other thing that we have is the data aggregation. And again, this is very important because not only is this a platform for simulation, it's also a market intelligence platform where we would actually provide information such as what's available in the market, what kind of technologies are working best, what kind of financing is working best, what kind of cutoff points do you have for payback periods, etc. And then we need to have an aggregation engine to be able to assimilate all the data of actual market things happening, and then provide that as an insight back to the users of the platform. So yeah, this is what I want to show you about the modeling methodology that we have. So essentially, you might be familiar with these type of models. I've classified them into three, and again, actually took some of the references from different open sources to just put this up. Essentially, we would typically have empirical models that you could use. You would have steady state models, and I think most of you are familiar with dynamic simulation models such as Energy Plus or IES virtual environment or Princess or any of those that we also use. What we do is basically to use these models wisely in the platform so that we can actually take it with the data approach of providing a physics plus AI tool. So we use empirical models for benchmarking and data gap filling wherever required. So basically we have a script running, machine learning script running, where we take the rules of thumbs, for example, for every square meters, what is going to be your occupancy, put that into our script to say if there is a new entry coming up, how could you update that on an ongoing basis, and then use that for a gap filling of our data entry tool or for the data gathering, so that we can have an accurate model of the building. So that's the empirical models. We largely rely on steady state models, basically, these are, you can imagine, steady state heat loss models, for example, or simple methods to do diagonal or annual basis averaging of different variables in the building. And it is used as an accumulated temperature difference or degree days methodology that people use for heating and cooling. So basically, that's the steady state modeling methodology that is used by different parties as well. We use that basically to do our quick baseline calculations and energy saving analysis where specific data is not available. So for example, if a building has no BIM models and accuracy is expected to be lower, we actually can use a steady state model to go further. Then we have, like I said earlier, we started using different dynamic models available openly and developed our own scripts to be able to do dynamic simulations and use the weather patterns and weather files appropriately for that particular city, so that we can do a detailed assessment and calculation for our manual simulation that we provide on the platform. And of course, that is continuously calibrated by the data that we get, so that we achieve building models which are continuously calibrated. So now you can imagine that we start with simple models like empirical models, go on to statistic models for where we require keep on filling the gaps in data, and then we further go into a more accurate model by, let's say, uploading a BIM file and then looking at how the building is, looking at more details of the building and developing a clearer dynamic model of the building, right? And then making it available for the rest of the industry. So that's our modeling methodology on the platform. We are actually, of course, a commercial tool. So what we are providing for is a opportunity for consultants, building owners, sustainability managers, ESCO companies, as well as technology suppliers to use this platform as a tool for them to get further. And we offer that as on a freemium mode, meaning that some parts of the platform are free and some parts are premium that you need to pay. These are the typical costs for a. So let's say we focus on the left-hand side, the tool called EDGAR, the Enhanced Digital Green Assessor. We make this available at a particular cost of a few $1,000s per user per year. And for that, basically, you'll get access as a consultant or a ESCO company to several tens of thousands of buildings in the city, where you could basically literally drag and drop your ideas and see, do a quick simulation and get an 80 to 90% accurate modeling of your green project, and then put it up for, let's say, for financing or to the building owner for proposals. So that's basically the support that we provide to the tool called EDGAR, the Enhanced Digital Green Assessor. And on the right-hand side, you will see the product inclusion in assessment. This is another subscription model that we provide for including products in assessment. So if there is a company who is new to the market or would like to make sure that their product is going to be used in assessments by consultants throughout the city, they could actually then pay a small subscription and get their product through a one-time inclusion that we do and continuously updating their product parameters on the platform. We are able to provide them an opportunity to reach out to consultants or building owners without them even knowing. So what I mean by that is typically a cycle of a product owner being modeled or a new product being modeled in a tool like, let's say, ISV or an energy model, is that the consultant or the modeling expert has to know and understand the parameters of the technology and then model it appropriately with the building. Right. So what we are doing here is to basically kind of front load that modeling part and digitizing the technology parameters into the building models and making them available appropriately for the right buildings. Excuse me. So what we mean by that is that we could actually use the intelligence of the platform to suggest this technology to the right building. So for example, if it's a central chiller optimization tool, we would not suggest it to buildings which are using, let's say, split units, and so on and so forth. So basically, it becomes a nicely available information or a mix and match kind of a tool that I will show you later on in the demo, where the product will be now included. So we're actually offering that as a service as well. So we are also curating a huge list of industry specialists, and that's our goal, to basically become a platform where you could find consultants, experts, as well as data for buildings. So we have actually now modeled the entire, or rather big chunk of buildings in Singapore, and we're doing that further for other cities. We've also started curating open source databases. So basically we had a team which looked at scraping databases for, let's say, CleanMark, lean professionals, and we've actually gathered a huge amount of database. And you might actually be able to find yourself. So when you go to the listing platform, a list of it that I'll show you later on, you would actually pick up a listing. You can just join for free. And then you would, if you're getting contacted, you can actually pay per lead, or you can join as a premium listing just for a small fee per year. So this provides an opportunity for consultants, ESCO companies, building owners, as well as technology providers to highlight their projects that they have done. And just like a LinkedIn, provide a facility for creating something outside your website, which is openly and neutrally available to people to look at. Lastly, we're also looking at tools for green certification, such as we have now started with the Green Mark certification tool. We call it GRACE, the Green Auto Certification tool. Essentially, just imagine this: that certification itself is a task that needs to happen, and there's a lot of data issues that happen during certification as well. If that data is made available in a platform which should be transferable year on year, then we have a winner which could actually help not only the consultant but also the building owner and the technology providers to assess buildings quickly and assess the potential for upgrading the green certifications wherever required. So right now we have this tool coming up ready for Singapore, which will be launching in September. It's basically commercially launched in September, but it's already becoming ready and made available on a beta version. We would then look at other certifications in the region, such as the BEAM and ECBC India. Then we'll actually look at LEED, BREEAM, and neighbors. I know that there are certain tools available like this in the market, but again, this would be something that we start from Asia and then propagate to the rest of the world. So actually, this is a section where I typically show videos and demos. So instead of doing that, since I'm talking to you directly, I would like to have an opportunity to actually do an actual platform demo for you, if that is okay. So Jerry, could I just check with you also, how are we doing on time and if there are any burning questions so far?
So yeah, we're doing good. Yeah, you can just show your demo. It'd be great.
Okay. And also to check, are there any burning questions or clarifications that I need to do before until we wait for the Q&A?
I think we're good. Just if we can slow down a little bit so we can hear you better, that'd be perfect. Thank you.
I see. Okay, got it.
Thanks.
All right. Okay, so essentially this is our platform that you can. I hope you can still see my screen. And basically, this is a platform that we have, the open source data platform that I mentioned. So what we have done is basically to take Mapbox and OpenStreetMap based mapping tools to create block models of buildings. And then we are then going to use those models to do all further analysis. So what we would do is basically pick up a building. You can click on a building, look for details of a building, just like you would see on a Google map. Then you will see the overview of the building, let's say the floor area, type of building, number of floors, etc. Look at the certification that it has achieved in the past, look at the energy use intensity of the building, and also look at the energy saving potential of the building. So this is something that we have calculated using our tool, using our AI tool, based on the data that is available for the building. So if the consultant has put in more data, the accuracy of this energy saving potential is improved further. That's why we have this marker here called the digital twin accuracy, which tells you how accurate this digital twin of this building is right now on the platform. And how does this building compare to other buildings in the city, similar kind of buildings? What is its EUI scale rating? And how we could actually improve is the next step. So apart from this, we also have some kind of empirical or high-level comparison tools, such as Compare tool. You could actually compare buildings with other buildings in the cities. You could actually pick up some other buildings and do a quick comparison of different parameters. And we're making it available now wherever possible. When the data is available, you could actually make a quick comparison of different buildings and put them side by side and check their parameters as to, for example, what is the energy saving potential of different buildings and what kind of floor area is there and how should you attack if you're a consultant or a technology supplier, which are the best buildings for you to go with. Or if you're a building owner, you could use this data to benchmark your own buildings. We've also made a search tool on the platform where you could actually search buildings, let's say by the typology, by the energy use, by the floor area, by number of floors, and other building details, so that you're going to get a quick overview of buildings in the city, and then you can do the same, pick up a building, and go further with the analysis. So basically that gives the quick overview of the open tools. So this is practically available to as a free login. Then we would actually move to the areas where we start charging on the platform. And that is primarily the add data portion, where I mentioned earlier that we have a AI-assisted data entry tool. So before you add data, a consultant or a building owner has to claim the property as an owner or consultant. And then we will do a quick check on them and allocate the access for them to add data to the building. So this helps us to make sure that the data is not misinterpreted or not overridden by something wrong. So this add data tool is basically a tool which takes you through the And you could say the design template of the building, and helps you to add operational data as well. That also you. So essentially, let's say you look at the overview of the building, the type, the floor area. Again, you could override data here, and there'll be calculations done on the fly. So if you're changing the floor area, you would actually get the occupants number change. But if you know the exact numbers, you would also put them up here. Then you could also be able to add advanced data if required. So again, if you're just in a hurry, you could actually just quickly just accept all the data at overview and just start generating a baseline report. Or you could actually give more information so that you can get more accurate results. So this year we are spreading up the building use by different areas. And that same thing would be then used for defining the HVAC and lighting parameters as well later on. We could also collect operational data, such as the building energy use tariffs, the operating hours of the building. This could be then modified quickly. The overall energy consumption, this is again a calculated number. This could be overridden by the actuals. And you could also put in energy bills if required. We're also making a DCR tool to capture energy bill information by just simply uploading your energy bills. You could actually select the start of the year and then the month that you're providing for, and then you would get the bill organized accordingly. And then you can also override and enter this if required. So again, this is a way for you to enter advanced data. And there is also possibility to go into much more detailed scheduling of inputs, such as you could schedule the different spaces which are there if required. Again, if not provided for, we actually assume the schedules based on templates, open source templates that we have, and the machine learned data that we gather. So let's say we are just going to go for with those. So it's a basic data. We're not going to go through all the details, and then we are going to just go further. So then we look at the construction template of the building, what kind of floors it has, floor to floor heights, air conditioned, non-air conditioned area, window to wall ratio. And if possible, with the advanced section, we're able to provide even more detailed window to wall ratio per facade. So if you have 3 facades, you could actually key in all the 3 facades here. Or if you have 5, you could actually key in as many as you want. Yeah. So essentially with this, you will be able to give precise information about the facade that you have. Again, this need not be a data entry tool. It could be simply automated completely by a BIM model. Right? So that's the integration that we would have. You just upload your BIM file and then you're done with this. You don't need to enter this data anymore. Lighting, we would start with simple things such as what kind of lighting overall you have. You could define lighting by space. You could define the lux level, let's say regulations or that you provide for. You could select that lighting type, the controls that you have, and then be able to simulate the lighting energy calculations as well. HVAC, we would do the same. You would actually look at the different systems that you had. You can add more systems if you want. And so you can actually add a system too, which will be serving certain areas. And later on, you can define the room data as to which area is using which HVAC technology and what are the systems that we use. So for now, I'm just going to just go with one. The system TR is automatically calculated. Again, you can override this by knowing the actual TR that you have. So let's see if I know that my building is operating at let's say 5,000 ish. I could actually override that and move on with the calculations. So then we actually go to the miscellaneous data where we add further data around other parameters such as lift, escalators, renewable energy systems, water pumps, BMS systems, cameras, EV charging, etc. And then if nothing is there, you can just basically reuse this and just generate a quick report. So when I click next now, the tool is going to generate a quick baseline energy consumption report, which shows the energy use, basically matched to the city high and city low. We'll get a quick split of energy consumption in terms of the different facilities in the building. We get a breakdown of the usage patterns in monthly as well as in daily averages. And then basically this forms a good parametric analysis for looking at your, the performance parameters as well, such as the EUI, the OTTV, ETTV, the thermal transfer values of the envelope, and then the lighting power density, the HVAC, renewable energy usage, etc. So having made this nice baseline report, then you could now start doing your simulations. So we have provided for an auto simulator, basically again an AI script, which will now look at your baseline data, match it with the best technologies available on the platform, and they come up with a table like this, which says you could potentially save 26% in this building by investment of 6 million and a payback of 7.2 years. And these are the 10 things that you could do in your building to achieve that. And not only that, you're also providing for a link to the platform that I mentioned earlier, which is a listing platform. So we could actually make a list of technology suppliers in the insulation domain or the building envelope facade domain, and you would link them to them directly. So you can actually have this. And in future, we are having another integration with this tool where you can just simply drag and drop this into your manual simulation. I'll come to that in a bit. So the auto simulation tool itself gives you a very quick overview of what could happen in the building using the scripts that we have. So for financiers, this is a good overview tool that they could use. For consultants, this is a tool that you could use to start a discussion with their clients. And the same goes with technology suppliers. And so they could actually say there's an opportunity to upgrade your air conditioning based on the data that you have provided to the platform. And then let me help you do that. I have a nice technology that fits in nicely with one of these auto simulation tools. Now, we could save this, send it to the building owner. We could also do manual simulation. So here we are talking about energy saving potential estimation on a manual basis. So we would actually then select the specific energy saving measures that I would like to do. Let's say I would like to do building lighting retrofits. I select yes. I would select the light retrofit. So they already have LED basic. So let's say I will choose best in class LED, and then maybe I'll choose some controls, occupancy sensors, and I will choose daylight sensors. So if all works well and the calculation is accurate enough, it will show you now estimation of the energy saving potential because of lighting that the building could achieve. So you notice that it's about 6% with a payback of 5.2 years, notably because they already have LED installed. The delta may not be so much. Then we can go to HVAC and basically keep on adding to the total energy saving potential. So let's see if I'm doing an HVAC retrofit, I can select the ECMs. Let's say I do only this. And that's where I mentioned that you could actually drag and drop some of these technologies which are available on the listing platform. So we have made provisions for solutions in the HVAC domain as well. And if we have the parametric details made available to us, we can drag and drop these units, for example, to this building if it makes sense. If it's not, it will show an error. But essentially, if it does make sense, it will do a calculation for you to find out what would be the benefit of that technology upgrade in terms of your overall energy saving potential. So then you can finalize this report and send it to the building owner. So that's basically the tool that we have developed. I hope that gives you an overview of what we do. Sorry for if it's not clear, but you could always clarify during the questions, and be happy to discuss further during the Q&A as well. I'm going to go back to the slides for a bit and then end with some concluding remarks. So I hope you can still see my screen, and I'm going to go and show you one more slide, which is about the validation of this tool. So we started validating this tool for using the open source available building energy submission system in Singapore called BESS. So this actually has building data, energy consumption data of buildings as a mandatory disclosure. And we started benchmarking that with our platform calculations. And we found that we are able to achieve decent amount of accuracy off the bat by not having even a BIM integration. We're able to achieve around 90% plus accuracy in terms of our modeling capabilities on the platform. So a tool like this actually is able to offer you, we were hoping for 80 to 90% accuracy, so that it's useful for technology providers to make some early decisions and for financiers to also make early decisions. Now, if it's available at a 90-95% accuracy, you could actually practically replace that as a simulation tool for retrofits. Okay, so I think with this, I will take a stop now and see if you have any questions that I can address. I'm happy to discuss further on potential collaboration opportunities as well. Back to you, Shelly.
Okay, thank you very much, Nilesh. That was very technical. Thank you very much for all this information. And it seems like it's very well integrated from financial to the manufacturers to the models. And so it seems like a lot of work has been done. So my question actually to start is that if a country like Canada wants to start adopting this platform, how much work does it require to start?
Okay, so essentially we have looked at Canada specifically, we've looked at a few cities. There is a good chunk of information available already in the OpenStreetMap model. So we could actually start with that. We could create and curate these models already. Then we can do some quick calibration based on open source data, which is available for, let's say, the city disclosure data for buildings. We could pick up a good sample and do a validation. Once we have that, we actually put the weather files and the weather calculators there that we have for the dynamic simulation. We do a quick run preferentially with a partner who has that data and can help us validate, and then we are set up. Then we can basically, the process follows, right? Because then we have a possibility for users, let's say consultants, to go in and input that data further. So then we can continue from there. Yeah. So it's a matter of, let's say, a good 2 to 3 months of preparation. that we would need to start with the map-based tool, put data into some initial validation, and start operating in the new city.
Okay. Oh, that's great. It's not too long. So 2 to 3 months is,
Yes,
good to
yes,
start with.
yes, yes.
Okay. We have a question from the chat. How
Yeah.
do you add individual building material values from manufacturers into your simulation?
Okay, so basically that is provided for, and I went over that very quickly in the construction template. So essentially, we are able to add insulation, glazing, material properties at the add data stage. If it is not provided for, basically we work on the codes. So basically we take parametric code-based values for building materials and simulate. If it is provided for, that means we know the specific material that is used. We then use the parameters of that material and then use that in our simulations. And then basically when there is a change, let's say retrofit could happen, if somebody's providing a better insulation, or let's say a paint or pool paint, we are able to then provide for that and then affect the specific value. It's if you have a pool paint, could we then affect the thermal properties of the envelope suitably in our building simulation, so that we can get the energy saving potential calculations done.
Okay. I hope it answered your question, Zikora. If not, please ask more in the chat. So for now, let's invite back Kelly into the conversation together. Thank you, Kelly, for waiting. Okay, I think you're okay. Perfect. So in this part of the section, we will continue receiving questions, and in the meantime, we will kind of talk about a larger scheme of things. So both countries, it seems like Singapore and Canada, we are all heading towards sustainability and greening the government, and a lot of policies are being in place. So in both of your perspective, in a hyper level perspective, how much percentage of the passive house design is implemented in the country, or digital twin using the virtual energy audit is being implemented in Singapore? I will start with Kelly.
So sorry, the question was how much passive house is being implemented in Canada?
Yeah, about percentage.
Okay. So I'm not entirely certain on like a percentage across the board. I know that passive house and sustainability projects across the country are being picked up seemingly exponentially by municipalities predominantly. We see a lot more work coming from cities, social housing, that sort of thing, where they are looking to reduce their bottom line, improve their energy performance of their buildings, just because they can see the long-term goals of reducing their energy requirements and improving the resiliency both for their occupants and for the buildings themselves. When it comes to a percentage, I think it's hard to really kind of provide a finite answer, because a lot of people, when you're looking at residential housing, they may not want to go for certification, they just want to build to a better standard. And sometimes we often find the same thing with municipalities and affordable housing, is they just want to do what they can to reduce their reliance on fossil fuels and the carbon emissions and generally improve the performance, but maybe not go for the certification. But it is picking up steam. Sustainability as a whole and the carbon initiatives that we've got, both federally and provincially, are making a difference and raising awareness for reducing emissions.
Okay. So I have more questions on that. However, we will just start talking to Nilesh for a bit. So what's your perspective?
Yeah, so of course, passive house standards in Singapore are, I would say, at a very early stage. Passive, of course, started as a concept in Europe, if I'm not wrong, Kelly, where they actually looked at how we could have a perfectly insulated place which will reduce the heating demand quite drastically. That was the beginning, but of course it has evolved now to a very comprehensive approach of looking at building overall improvement of performance of the building. Still quite an early approach in Singapore. People are promoting that, but maybe just to answer the question a bit differently, energy modeling overall is actually used in Singapore for more and more in buildings. And from the regulation point of view, energy modeling is mandated for higher certification levels. So if you're going for the green mark certification, equivalent of LEED, let's say platinum, then you would need to do an energy model for sure in your building design project. If you're going for low certifications, then you need not do an energy model. You would actually rely on simple calculations if you want, or somebody else would do the energy model and you do not need to submit that the regulatory bodies.
Mhm,
So that's
okay.
that's a level of development that we have in Singapore. And just to give you an overview, right now Singapore has greened about 50% of its overall building stock. The target is to have 80% buildings to be green certified by 2030. Right now we're around 50%, out of which I would say around 20 to 25% are the higher certification ratings. So that would be the rate of adoption of, let's say, an energy modeling approach in Singapore.
Mhm, that's great. We have a question, Kelly, about why do we have more of a residential buildings than passive house in Canada website? Can the principle be applied to gymnasium center?
So this is a question we get all the time in the passive house world. So passive house, when it's spelled in the German way, ends with H-A-U-S, which doesn't actually translate specifically to house, it translates to building. So the principle itself can be applied to any building. Generally, we do see it firstly with an uptick in Canada for the residential application, especially a lot on the social housing front and affordable living, because the communities or the organizations that run or want to develop more housing are keen to have that energy reduction and the improvement in occupant health and the resiliency that's offered as well. So we do see a lot of it right now with single family homes or multi-residential developments, but there is a lot more coming. Like I said, from municipalities for other types of buildings. We've assessed fire halls, transit hubs. You can definitely put it into a gymnasium center. There's also like swimming pool, like facilities that are passive house as well. It can meet any building typology. It's all about energy reduction and high performance building.
Okay, that's great. We have a question coming up about the Singapore project. Before I move on though, Kelly, is there such thing as a luxury passive house? But it seems like there are a lot of affordable housing projects are using passive house design, but is there such thing as a luxury version of a passive house?
I guess it would just depend on what your finishes would be on the inside. Across the board, like your envelope, your glazing, all of that's going to generally remain the same. It's, I guess, how you want to finish the inside of it. A lot of the single family homes that I've seen be certified can be deemed quite luxurious. But yeah, for social housing, the projects we do is generally like bare bones. You get, you know, the simplest things you can get in there because the budgets are tight. So it's all about making the performance good. And not necessarily the interior aesthetics, but you can have that. It just depends how much money you want or how much money you have.
Yeah, that makes sense.
Can I ask a follow-up question to Kelly?
Sure.
So Kelly, as per what you know, is there a study done on the premium that you would need to pay for passive house designs typically compared to a building which is not designed as a passive house?
So it really depends on the market where your project's located. We find that there is a wide variety in trade experience and understanding of the concept. Typically, we have some projects on our own deck that have come in for like under a 1% cost increase. But typically across the board, we generally say 5 to 10% because it depends a lot on the location, material shortages, and that kind of stuff. And it's really hard to speculate that now, especially with construction materials being shortaged everywhere. So typically it's within that 5 to 10% threshold. But again, it depends entirely on a lot of different like factors. You have to.
Yes, absolutely. We have also done a study in Singapore where we found that the green premium, especially for platinum rated buildings, is around 5 to 10% as well. It can go up to 20% at some projects, but the more importantly, the payback is also quite decent. It's basically ranged between 3 to 8 years for platinum certified buildings, and more buildings are getting into the stage of lower paybacks. And I think you're right. It all depends on the design. You could actually have, in fact, no premium if you do a proper design. Right? I mean, need not have a premium at all if you actually do a good design, you plan your natural ventilation spaces, etc.
We employ like an integrated approach too with all our consultants. We get the CM, like a construction management, on board early, so that a lot of those extra costs you might see that come up through construction or later on when your builder gets his hands on the plans, that can all add to costs. So we bring in everybody that we can from the very beginning. So that also aids in a reduced overall cost for the building. So we can value engineer as we go. We can make sure that things are going to work. We have all that coordination happening from the get-go.
For sure. Getting early with all the contractors are always very helpful. I come from the construction management company as well previously, so definitely I see the benefit of that. So another question, I think this is for Nilesh. I will answer this live. The Singapore project is really impressive. What was the driving force of digitizing the buildings of the city? To be able to compare the benchmark them and to better assess the retrofit investment.
Yeah, I mean, essentially all of the above. The Singapore is actually promoting itself and also really doing a lot of work in being a smart nation, and digitizing buildings, digitizing the construction sector is really part of that. So Singapore has what I showed you was our own work that we have done on our own platform, but there is parallelly a virtual Singapore project that actually can go into much more details, and that we are also going to have some plugins to them. So you can actually look it up. The virtual Singapore project has made parametric semantic models of also thousands of buildings in Singapore, and you could do flying walkthroughs also of existing buildings, and it also allows for new building designs to be planned through the space planning products that they have. So this tool is right now, the virtual Singapore project is primarily used by the Singapore government agencies right now, but it's made more and more available openly to be able to do the things like what was asked in the question, such as benchmarking, comparison, and also do possibly calculations for retrofits, like what we are doing on our platform.
Yeah. That's great. It seems like the Singapore government is really helping in leading the industry to go to that direction. So any other questions from okay, so I'm getting another question. Is it a must need for an architectural designer to go into building energy simulation? Kelly or Nilesh? Kelly?
Yeah, I'll start that, maybe Nilesh. I like to say yes to that. Your energy consumption for your project should always weigh at the forefront of your design, especially in today's world where I like to say money today costs less than money tomorrow, and energy today is much cheaper than energy tomorrow. So you want to make sure that whatever you're building over the lifespan that you expect it to be up for, like if that's 50 or 60 years, is going to maintain and constantly improve on its performance, whether that's through updated HVAC, but you always need to make sure where you start. And you have to make sure that your design is going to be as efficient as it can for today.
Great. Yes, I agree. Nilesh, do you have any insights as the energy auditor?
Of course, I fully agree with Kelly for sure. And I just want to, I mean, the question is a bit, could be a bit broad in terms of the angles that you take. If you take a pure expert angle, like what Kelly does, or I would do, or what you do, Jalen, the answer would be yes, a resounding yes, right, all the time. That it makes so much sense, right? Why would you go for it? But then again, like I said, there are other considerations such as cost, expertise. So we also see that energy modeling tools today can be considered expensive, not only from the license that you have. Energy Plus is free, right? But it can still become expensive because the specific knowledge is required in a person who can actually run that simulation, right? So that costs more than the tool itself. So that becomes sometimes prohibitive for certain projects, especially small projects. If you're designing a small house or a small building with a very clear block model, you're not doing anything fancy. I think it would be an overkill to do an energy model. I would still recommend as a technical person to do it, because then, like what Kelly said, you could actually think about approaches to save energy, even in your small space, but then the cost might become prohibitive. Your entire budget might look a bit lopsided in terms of energy simulation expertise. But if you have medium to large facilities, highly recommended and absolutely a must. And that's the reason I mentioned earlier that the Singapore government, for higher certification, I think the LEED also does the same. You need energy modeling, and you need to even submit your energy modeling models to the certification bodies to assess. So it's a highly useful skill. And as from the third angle of future development and digitalization, I would say it's a must. Right? I mean, we are going to lose on, if you are a consultant and you're not familiar with energy modeling, you probably lose on a lot in the future.
Mm-hmm. Right. So what do you, I think we just talked about buildings specifically and energy auditing and energy modeling of the buildings. I know this is outside of maybe your expertise area, civil infrastructure. In terms of civil infrastructure, would that be something that we can apply to civil infrastructure from today's topic?
Yeah, I would say yes. I mean, civil infrastructures, we have also looked at airports, train stations. I presume you're talking about those. Of course, the energy used for a bridge is not much, or nothing, I would say, unless you put some good lighting on that, and then you want to have a air-conditioned cabin below the bridge. So again, things are getting more integrated, right? So I think it's a very good question, Jalen, because as you plan cities which are dense like Singapore, you tend to have this kind of an integration opportunity. So somebody will build a bridge, and below that you'll have an air-conditioned cabin for a construction manager or somebody, and then your energy needs become important. So your energy modeling could also become more interesting. But right now, of course, buildings are the most prominent one because it's well understood, and you can quantify the savings, and you can actually see the savings in the long run quite easily.
Mm-hmm. It seems like it's a good starting point. It has a more known values to us. Kelly, do you have any comments?
No, I agree with everything that Nilesh just said. It's great.
Okay, now I'm going to touch upon a little bit like a sensitive topic, I think, is that data sharing, data residency. Every country, they prefer the data to reside in their own country, especially for like a federal government projects, maybe high security projects. So, and even for the private sector projects, between the private owners and the consultants and the constructors and the trades, the data sharing is always a sensitive issue. Who owns the data? So, would you like to comment on that, Nilesh, first, maybe?
Okay, sure. Yeah, I think this is a topic which is very important for me, developing a data-based platform. So yeah, there are approaches, and we have encountered several building property developers who are we consider the data very sacred. We've actually proven them wrong because we can find a lot of their data from open source without them knowing. You could find a number of flows. If you're a hotel, all your data is practically up on your website. To make it like a nice selling tool. So we could use that data. So it's just that the data is sitting in different pockets everywhere. And you could actually have your own data, precious data with you. But then if you share the data, you're actually helping the community to basically design better buildings, but also yourself, right? So on our platform, we're offering opportunities for consultants, technology providers to basically go and suggest technology to the building. So basically, if they provide the data, make the model more accurate, they are going to help themselves in the future to be able to kind of open up an innovative approach that anybody could now suggest things should be. Also, there are mandatory disclosure modes. For example, energy consumption data disclosure is becoming mandatory in many places of the world. Singapore is there. I think I'm sure it's in Canada to some extent as well. And that basically is the data which is then made available through open source channels. So we had a building developed in Singapore which said, no, I can't provide you that data. But I just went to the government website and I could download the data for the past 3 years of energy consumption, right? Because they've already provided for that. And when they provided for that, the government side has made it kind of in their terms and conditions said that it's going to be available to everyone, and for their analysis, right? So it's basically a good thing that people are looking at data transparency. And especially data transparency in the design stage also helps a lot. And that's what I've actually put in my LinkedIn article, that people don't share data. And if you don't have a integrative design approach, like what Kelly mentioned earlier, people make huge mistakes in terms of designs. Architects put cooling towers in the wrong place. Engineers actually look for spaces of chillers in an area which is not properly load bearing. There are a number of things that could happen that could go wrong in the design stage. And in the later stage, if data is not being available, you would actually be kind of probably having a design fat or the design margins, and then you'll keep on having extra consumption of the design margins throughout the building life cycle. So yes, I mean, data, I mean, I cannot emphasize more on the importance of data transparency, but then in an ideal world, it would be shared, but there are still ways and means to basically get that data out. And that's what we're trying to do.
Yeah, data transparency sounds very, very important topic, and something that it seems like you looked into it a lot, and we appreciate your insight on that. Kelly?
I'm all for data transparency. I agree with Nilesh's approach. Like, you need to have that in order to have those collaborative efforts within a project, or even with anything that you're building. I'm all for it, and I agree with Nilesh's points.
Yeah, coming from the constructor's standpoint in my previous position, we always had a hard time getting data from even the models from the consultants, you know. It seems like throughout the life cycle of that model, even during the construction stage, once we receive the model, it's very hard for our consultants to update it throughout. You know, when the new changes coming out, we update it as a constructor. However, it doesn't go back and forth. So how's in your practice?
It's about the same. There's always that disconnect towards the end, which is why I really like more of an uptick with facilities management usage for like after construction. If there was actually a use for these models and a use for this data, we wouldn't have that gap, because you have to maintain it all the way through. So I'm really, really eager to get into one of those kind of projects where we do have to do that, and we do have all of the information we need, and everything is kept current and up to date. I'm really looking forward to that part of my professional career. Not sure when it's going to happen here, because we seem to be a little bit slow on the uptick of that kind of stuff. So eventually, I'm hoping.
Yeah, I was feeling the same previously. But if that facility management kind of portion becomes unnecessary in your project, do you see that the update of the model will be continuing during the construction phase, or just at the end, the handover, you will give the model for the facility management purposes only? I don't know if my question is clear.
I like for the information to be updated as it's being changed and not at the end. Especially from the work that I do in our projects, that often happens because I need to have the most up-to-date information, especially when we get towards the end of construction for the passive house validation. We need to know what it looks like. We need to know how it's ended up. And often that's not how we issue, for permit or tender. There's always changes that happen in between. So I like for it to be updated throughout, and generally that's what we do on the architectural end in our models. Our consultants can lag behind, as you are probably well known and well familiar with, but we try our best to get it there, and eventually with hopes of it actually being more commonly not accepted.
Yeah, that will definitely save time and money for everyone. Nilesh?
Yeah, I was just going to say that, unfortunately, BIM dies young, right? What I mean by that is BIM is still young in terms of the adoption rates, and it dies young. The building can stay for 30, 100 years, and nobody looks at BIM afterwards, after the building is constructed. So that's something that actually is changing. I mean, we are trying to do that, but also there are companies who are looking at BIM for FM. So where you actually look BIM, how could you use BIM in the facility management aspect? You could have a wealth of information there, right? And of course, if you keep on updating your BIM models, then you would have that continuous performance improvement approach that you could imagine. Right? And it just helps, actually. I'm not sure why we are not moving towards that. Maybe the complexity of BIM and maintaining the cost of that probably is prohibitive, but it only makes sense to actually have that updated. I mean, not only during the design stage, but also after the building design.
For sure. We have another question from the audience. When using Dynamo for the energy data, do you consider the categories and items flow of PHPP Excel sheets so that when exporting to Excel, it's well coordinated with PHPP required data?
Yes, is the answer. In short, what we do is we organize all the data we're exporting from the BIM environment specific to how PHPP wants to see it. And we generally import all that data into a separate standalone worksheet that is already linked to the individual tabs we have to complete or fill out on the PHP. So it's not a direct export to the cells within the PHP. It's a step in between, and that's so that we can control some of the data and make sure that it's properly organized outside. So that provides that step of check. But yes, long answer short, yes, we do. We make sure that everything is tailored just as the PHP wants it.
Okay, perfect. Thank you for all the questions from the audience. And I think we have 10 minutes left. So I would like to ask you both the last question. So you have to be creative for this question. If you were given a magic wand, what did you wish for? Kelly?
A circular world where everything is reused and everything is efficient and everything is planned and everything is idyllic. That's generally it. Yeah. Yeah. Reduce, reuse, repurpose.
Yes, perfect. Nilesh?
Yeah, I like Kelly's one better, but mine is basically a bit more to what we're doing now in the short term. I would really like to have the data approaches be made more coherent so that we can actually have green buildings to be more, accurately planned, designed, and then also operationalized. So a bit more technical magic wand, but I hope that basically it's still an outstanding item that we have. I mean, all of us have to work towards that. Don't let BIM die young. Make it survive for longer if possible. See how we could actually bridge the gap in terms of handing over data and handing over information in different building stages, and then also look at how we could reduce our margins in building design so that we don't have that operational fat of the operational margins which are big and then we operate at very low performance. So that my wish would be to have more data transparency.
Perfect. Yeah, it seems like the repurposing what we already have, whether it's a model or whether it's a data or whether it's other resources, it seems to be a very important topic for us. And especially when we are all going towards the sustainable cities. Thank you very much for both of you for the topic and the discussion. So if our audiences want to follow you further, how can they get in contact with you, or do you have any resources that you want to share?
LinkedIn is the best. I think I got 2 follow requests just now, or rather connection requests. I've already accepted them, and yeah, that's the best mechanism.
Yeah, same here.
Okay.
LinkedIn
Kelly?
is the best approach yet.
Okay, yeah, we all use LinkedIn, so. Okay, perfect. Well, thank you very much for both of you. Audiences, thank you also very much. It's late, in the evening. Probably if you're in Canada, Ontario area, you haven't eaten dinner yet, so feel free to go and enjoy your dinner. And thank you very much for Nilesh coming from Singapore at 5 a.m. in the morning. We very much appreciate. And if you look for any further collaboration that you're looking for, then feel free to reach out to us, dbNCR, or other panel, Kelly maybe, or in the audiences, you can reach out to them.
Yeah, thanks, Jalen, and was good knowing you, Kelly, as well.
Yep,
I enjoyed the forum. Yep.
Thanks for the invite.
Okay.
It was nice to. Yeah.
All right. Well, thank you very much, everyone, and have a great evening.
You as well.
All right. Bye-bye. Take care, everyone.
Bye.
Bye.